Okay, we're going to look at Core 2 paper from June 2015, question 9, a differentiation question. We're looking at a cylinder in this case, so you need to be aware of the fact that the volume of the cylinder is pi r squared h, and the surface area has got two parts to it, 2 pi r squared, because there's two circles top and bottom, and the label part, which is 2 pi r h, because it's the circumference times by the height, and that's your rectangle there. So these are equations that you need to know. And the key thing with this, generally, one of the unknowns, in this case h, we're going to try and eliminate. They're going to give us either the volume is fixed, work out the surface area, or the area is fixed, work out the volume. So in this case, for this question, they tell us that v equals 75 pi, and they're doing that in such a way that we can then say v equals 75 pi equals pi r squared h, make h the subject, 75 over r squared. There's a little awkward bit here to do with cost of it. It says that the different costs for each part of it, it's £2 per centimetre squared for the curved surface area, that's the label, and £3 for the circular tops and bases. So how I worked out the cost then, I've got my pounds in just to make it obvious that I've got the cost of it there. So it's 2 times 2 pi r h plus 3 times 2 pi r squared. And the key thing I want to do now with this one, I can do that. 4 pi r times h, right, 75 over r squared, and then 3 times 2, 6 pi r squared. And I should have, hopefully, 4 times 75, 300 pi, r over r squared becomes that, r cancels out, and 6 pi r squared. And that should be the show of that that's in the question. We look at the question, there we go, c equals 6 pi r squared plus 300 pi over r. And in this case, even if you can't do the part A, we can then use this equation that's given to do the rest of the question. So that's my part A. Part B is quite straightforward. Differentiate it. And before differentiating it, probably a good idea to write it as a power equation. It's 300 pi r to the minus 1 plus 6 pi r squared. Write dc by dr equals, get our notation correct, times by the power, minus 300 pi, subtract 1 from the power, times by the power, subtract 1 from the power. Don't stick equals 0 there, it drives me potty. I want to see for max slash min, dc by dr equals 0, and then you can stick this one and then rewrite it, plus 12 pi r equals nothing. Move the minus term across, so I've got that there. Get rid of the fraction, 12 pi r cubed equals 300 pi, divide by the pi there, divide by the 12 to get r cubed equals 300 over 12, which is 100 over 4, which is 25. R equals the cube root, 25, whatever that is. Okay, and in that case there, that gives us the radius. I then need to stick that back into c equals and then press buttons don't work out the answer there. So sticking this value of r into that original form of the c, and then answer the question there. Okay, and for your 1 mark at the end, justify it's a minimum for part C. Do my second differential. So take my differential there, times by the power, 600 pi r to the minus 3 plus 12 pi, and as long as r is greater than 0, it means my second differential is greater than 0, so I've got a min at whatever the cube root of 25 was. And that's my 1 mark there. Okay, thank you.